How to make an ester, the second method. Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. In the second video, I'm going to teach you how we can make an ester from an ester. In my previous video, you have seen how we can make an ester from a carboxylic acid with alcohol in excess and in the presence of acid catalyst, and you form an ester. Okay. In the transesterification, what it means by trans is that we start with an ester and then we swap trans. I mean, there's an exchange of one ester to the next one. So in transesterification, instead of starting with a carboxylic acid, we're going to start with an ester. This is R1, this is O, R2. So, for example, in this context, if we have, so this is say R1, R2, R1, okay. So, if we have this ester already, and we want to change the R group to R3, something else. So here, for example, is O-methyl, and the next one we want to have O-propyl. So the method we're going to use usually in the lab would be transesterification. We simply swap the esters. Now, how to do that is that we can swap the esters by using an alkoxide. An alkoxide is an organic compound with an O minus. For example, sodium O-methyl, sodium methoxide. This is one example. I'll show you more. I'll show you what I meant by this. Yeah. Let's go on to the next one. This is already the carboxylic acid. I'm going to change this to not OH, R2. Okay, and then the reaction would be, you have sodium, usually sodium, the reagents are sodium alkoxide minus. Okay, and then usually you would have it in example ethanol. Then what would happen is you have R1, then you have D. Let me just, oops, sorry. I should have used the red one here. Okay, and that oxygen maintains or remains, and now we have a new oxygen coming from this alkoxide. So I'm going to put as R. I should have labeled as R3, yeah? R3. Okay, and Na, sodium. So that will leave as an alkoxide. Okay, that's done. Now let's see the mechanism. Mechanism seems to be simpler than the esterification of carboxylic acid with alcohol and acid. Let's take a look at this one, for example. So if we have an alkoxide, I'm going to, since we use already blue, we're going to use blue again. So if you have, for example, here an alkoxide, I'm going to just third butoxide. Yeah, you have this. Then normally you'd have also the opposite charge, which is lithium. Okay, and then that will be added to this ester. Notice here that there is no hydrogen, so the carbonyl is not activated by having a protonated head. Yeah, it's not protonated at all. So it will then attack the electrophilic carbon of the carbonyl, and then that will, oops, okay. So the next thing is that, let me draw this as an equilibrium. Okay. Next thing is that when that species, the alkyl site, attacks the carbonyl in this manner, it will open up the structure. The structure is open, so what you have is something similar to a tetrahedral. At the moment, this is actually quite flat. Yeah, this is the quite flat actually, just a trigonal. So here you have R1, then you have also D. This should be here in a sense, oxygen, tetrahedral, structure, something like that, just throw something, and I'm going to oxygen. Alright, and then you have the R2. This is oxygen from the. Okay. And now the other one would be the oxygen on the top there.
A few moments later.
Okay, so now this is the important moment for this molecule. Now it is in tetrahedral intermediate. Okay, this is now the important moment, because this is where this R2, this will live as an alkyl site in this case. It will live as an alkyl site. So what happens is that it will then, once the thing is open as an tetrahedral intermediate, it will then push back to, let's just go back into that, right? And this can leave. So bond forming, the bond is broken. Okay, and then again, remember this is equilibrium. And that leaves as an, you have the lithium and negatively charged. Oh, sorry, it should have been a OR2. Okay. So this is general transesterification. From an ester to another ester, so via the alkyl site, sample in this case. Right? Based on this, let me then show you a couple of reactions to illustrate this transesterification reaction. For example, if you have an ester, an aromatic ester, so here we have this. Okay, this is an ester. All right, and then if you have, for example, here I'm going to use maybe red, it's easier. So you have this sodium O, an alkyl site with a huge alkyl site, which is a ring. Okay. What happens is that it will attack on this one. It will replace this. This is already an ester. You replace this. So now what we have is, okay, and you have sodium plus, then you have O, phenoxide. Yeah, phenoxide. It's an alkyl site. Okay. If you have a ring, you find a lot of lactones in drugs. Lactones are acyclized esters, and then here you have this beta-lactone. Can I just draw this? oxygen. Okay, so now the oxygen of the lactone is in black. And if we do a very simple transesterification, you have sodium, and then this is plus, and then you have methoxide, okay, in methanol. Methanol as a solvent, this methoxide is reagent, okay, and then what you'd get is, so you probably have this methoxide attacking or replacing the side of the ester. Yeah. At the same time, what is interesting is it will also open up the ring. Okay. So what you tend to get is you get something like this. I'll just draw this side of the ring first. So we have that methoxide replacing the side of the ring, yeah, and it opens up to form the alcohol. So how many are there? 1, 2, 3, 4. So 1, 2, 3, 4, and gives you the other side is alcohol. This is interesting. So in this second method of making an ester, it's slightly different. Instead of starting with a carboxylic acid, we start with an ester and we replace or swap the group at the ester part. So in this case, we have an aromatic ester, we swap it with the cyclohexane ester. So very simple. In this ring structure, like this, one of these lactones, okay, we open up the structure and become a straight chain ester, very simple ester. And please do go through the mechanism. It's quite simple. When you have an alkoxide, there's no acid catalyst at all. So alkoxides simply attack the carbon, the electrophilic carbon of the carbonyl, and then it will form the tetrahedral intermediate, and then you get the ester with the original ester forming the alkoxide as the byproduct. Right, so that's all for this video. I hope you have learned something about transesterification. The key word here is trans. Yeah, swapping the two groups of ester from original to the new one. And with that, if you have any comments or any question, let me know in the comment section, and I see you in the next video.